Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 सीबीसीएस ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू
हेलो स्टूडेंट्स आज टॉपिक रे आमे न्यूक्लियर फोर्सेस एंड देयर प्रॉपर्टीज विषय रे पढ़िबा सो आमे स्टार्टिंग रो देखिला जे दुईटा थ्योरी गोटे है प्रोटॉन इलेक्ट्रॉन थ्योरी जोटा भूल प्रमाणित है आ गोटे है प्रोटॉन न्यूट्रॉन थ्योरी एज पर व्हिच अ न्यूक्लियस कंटेन्स प्रोटॉन्स एंड न्यूट्रॉन्स नाउ वी नो दैट protons are positively charged particles and neutrons are neutral particles. Further, these protons and neutrons are very closely packed together inside the nucleus, which is having a size of the order of 10 to the power minus 15 meter, that is 1 Fermi. Now, since protons are positively charged, so as per Coulomb's law of repulsion, we have an electrostatic force of repulsion between these protons, and this electrostatic force of repulsion between the protons should cause disruption of the nucleus, and hence the existence of nucleus will not be possible. Now another attractive force of gravitation between the proton-proton, proton-neutron and neutron-neutron masses will exist, and the nucleus will be considered to be stable due to this gravitational force. Okay, but it is found that the Coulomb's repulsive force is 10 to the power 36 times greater than the gravitational attractive force. Okay, तेणु Coulomb repulsive force रो magnitude बहुत बेसी रहउची 10 to the power 36 times रहउची as compared to the gravitational attractive force. That means there must be some other type of forces which is responsible for binding the nucleus, that is binding the neutrons and protons inside the nucleus. Okay, so এই जो force जो other type of force आसिला, these forces must be short range and very strong attractive forces, and these forces are called your nuclear forces. Okay, and these nuclear forces are highly complex in nature and they are different from both electrostatic and gravitational forces. Okay, now let us see what are the causes of these nuclear forces as per Meson theory. Now according to the exchange theory, the electrostatic forces between two charged particles is due to the exchange of electrons between them. Now the gravitational forces between two masses is due to exchange of gravitons. Okay, now according to Yuka theory, okay, Yuka jone scientist thile, so the nuclear forces between the nucleons might be due to the constant exchange of some particles between the nucleons. Okay, and these particles are called as your mesons. Okay, later on these particles mesons were actually detected. So प्रथमे युका एटा theoretically propose कले, तापरे experimentally यारो detection करागला ए जो meson रो. Okay, and mesons were found to have a mass which is 270 times that of the mass of your electron. Okay, now these mesons are actually positive, negative and also neutral in charges, and all these three types of mesons have been detected. Now according to this Yuka theory, the nucleons consist of some sort of common core which is surrounded by pulsating cloud of pi meson, and these mesons are rapidly jumping back and forth between the nucleons, and they change their identity fast, and at the same time they bind them together. Okay, now these mesons may be neutral, that is pi 0, or positive, that is pi plus, or negative, that is pi minus. So the forces between neutron-neutron and proton-proton are the result of exchange of neutral pi meson, that is pi 0, between them. and the force between neutron proton is due to the exchange of charged pi major, that is pi plus or pi minus between them. Okay, so as given below are the processes by which the nucleons are getting transformed into one another. Okay, so you can see here number of processes are given here. Here the neutron is transformed to a proton, and along with that a pi minus major is emitted. Then proton plus pi minus will give you a neutron. Then proton is actually converted into neutron by emission of a pi plus major. Okay, so similarly all other processes are also given here. Note that the process 1 to 4 here represent the proton neutron forces, which is due to the exchange of charged majors, that is pi plus or pi minus. Okay, and the process 5 to 8 represent the proton proton or neutron neutron forces due to the exchange of neutral majors, that is pi 0. Okay, and here also you see that the proton which is converted into a new state on exchanging the pi 0 major. Similarly, that of your neutron is converted into a new state on exchange of the pi 0 major, right? So in this manner the nucleons are held together due to the exchange of these pi majors between them. Now let us see the properties of nuclear forces. So these are like, number one, nuclear forces are short range forces. Okay, so here the nuclear forces between the nucleons exist only when the distance between the two nucleons is about 2.2 Fermi, that is 2.2 into 10 to the power minus 15 meter, and this distance is known as the range of nuclear forces, where the nuclear force has maximum value. Okay, so the nuclear forces will become negligible at a distance of 4.2 Fermi, that is 4.2 into 10 to the power minus 15 meter. Thus these forces are very short range. Okay, and this is shown in the figure also. You can see in figure we have taken the distance in Fermi in the x-axis and attraction along the positive y-axis, repulsion along the negative y-axis. Okay, so that it will have a graph like this. Okay, you can see it is maximum at around this 2.2 value, and it will become negligible around 4 or 4.2 Fermi, right? Now come to the second property. The nuclear forces are the strongest forces found in nature. Okay, and it is around 100 times stronger than the electrostatic force and 10 to the power 38 times stronger than the gravitational forces. Okay, hence the ratio of the gravitational, electrostatic and nuclear forces will be 1 is to 10 to the power 36 is to 10 to the power 38. Now the third property, nuclear forces are basically strong attractive forces, but they contain a small component of repulsive forces also. So nuclear forces actually come into action as an attractive force when the distance between the nucleons is about 10 to the power minus 14 meter, which is the size of the nucleus. Now the attractive force increases rapidly as the distance is decreased, and they become maximum at a distance of about 2.2 Fermi, as you have seen in the first property. Now as the distance is further decreased, then the attractive force decreases, and at a distance of 0.5 Fermi it will be changed to repulsive force suddenly. Okay, so the repulsive force will save the nucleus from collapse, and this is shown in the figure. You can see at 0.5 Fermi attractive force will become now repulsive. Okay, so that it will save the nucleus from being collapsed. Now the fourth property, nuclear forces are actually non-central forces. This means the force between two nucleons does not act along the line joining their centers, right? Therefore it is called non-central force. Now the fifth property, nuclear forces are charge independent. Okay, so the attractive forces between the nucleons inside the nucleus, and here one of the three types that we have seen, the force between the neutron proton, that is NP, then between neutron neutron, that is Nn, and between proton proton, that is Pp. So all these three types of forces actually are same. Okay, experimentally the study of mirror nuclides show that these three types of forces, that is Np, Nn and Pp, will have same magnitude. Okay, that means they will be independent of charge. Okay, so the nuclear forces are charge independent, right? Now coming to the next property, the sixth one, nuclear forces are spin dependent. Okay, it has been observed that nuclear forces between two nucleons having parallel spin is stronger than that of the force between the two nucleons having anti-parallel spins. Hence, we can say the nuclear forces are spin dependent. Then in the seventh property, the nuclear forces are exchange forces. This we have already seen in case of your Yucca theory of exchange of pi mesons. So the nuclear forces will have an exchange character, and these forces come into existence due to the exchange of the pi mesons. That is the neutral, that is pi 0, and the charged pi mesons, that is pi plus and pi minus between the nucleons. And the last property is nuclear forces are saturated forces, right? So nuclear forces exhibits a saturation character. That means a nucleon inside the nucleus does not experience a nuclear force due to all other nucleons. Rather, it experiences force only due to its nearest neighboring nucleons. So, as we observe from the fact that binding energy per nucleon becomes constant with the mass number above 40 and does not grow with the growth of the nuclear dimensions. So this implies that nuclear forces will saturate. Okay, we have seen that the binding energy graph, यदि हमें यही हिसाब रे binding energy graph पकेबा by taking binding energy along y axis and the mass number a along x axis, ताले यही भलिया हमरो ग्राफटा आसीबो. सो এই जो ग्राफटा देखो एटा पैरेलल हे गला a संगरे এই জায়গারে 40 যেতବେଳେ a ର ভ্যালু 40 আসিবো তাপরে binding energy পাখাপাখি constant রহিবো. Okay, so that we can say that the nuclear force is a saturated force. So once a nucleon formed few bonds, then it ignores the further addition of nucleons to the system. Okay, so this is all about the nuclear forces and properties that I have taken from one book. Now this is what I have taken from another book about the nuclear forces and properties. So you can see here it has given about the magnitude of the gravitational force which it has calculated, and similarly the magnitude of the electrostatic force, right? So that on comparing between the two forces we find that the ratio between the repulsive and the attractive forces, that is the repulsive Coulomb force and attractive gravitational force, is coming out to be around 10 to the power 36. Okay, which is showing that the gravitational force is extremely weak as compared to the electrostatic Coulomb force. Further, it has calculated the electrostatic potential energy between two protons which are separated by 1 Fermi, that is 10 to the power minus 15 meter, and it's coming out to be 1.44 MeV, that is mega electron volt. Okay, now moving further, it has also given in detail about the Nn, Np and Pp forces. Okay, so I advise you to read it also. So you can see these are the properties of nuclear forces as given in this book also. So again I advise you to find the valuable points and include it in making your note accordingly. Further, at the end it has given about the Yucca-Mason theory of nuclear forces in a detailed manner. Okay, so this you can also study for your knowledge purpose. You can see here the mass of pi meson that it has also calculated at the end. Okay, which was found out to be 230 times of your mass of your electron. Okay,
Thank you.